Welcome to the Joy of Architecture.
Great to be here.
Today we're digging into a whole stack of material articles, research notes, all about, well, the evolution of cross-platform app development.
Yeah, and specifically we're focusing on Flutter, right? Google's framework.
Exactly. We want to unpack these sources and figure out, has Flutter finally succeeded where some earlier attempts kind of stumbled?
It's that classic write once, run anywhere dream.
Yeah.
It's been around for ages.
Right. The appeal is obvious: save time, save money, get that consistent feel on both iOS and Android.
But actually pulling it off without big compromises,
Yeah.
that's been the real challenge.
Totally. I mean, native development gives you ultimate control, but wow, 2 code bases, that gets expensive fast.
And slow.
Yeah.
So yeah, cross-platform tools tried to fill that gap.
So our mission today, using all this research, is to really evaluate Flutter. How well did it address those historical challenges? Where does it stand now?
We'll look at the tech, the adoption metrics, and maybe touch on the strategic factors when you're actually choosing a platform.
Okay, great. Let's start with some history then. Before Flutter popped up, what were developers typically reaching for?
Well, one of the early big names was Apache Cordova. You might remember it as PhoneGap.
Oh yeah, PhoneGap. I remember that.
The idea was pretty straightforward.
Yeah.
Use your web skills, HTML, CSS, JavaScript, and wrap that inside a native shell.
Using a web view, right, like a header
Right.
browser.
Exactly, a web view. So for simpler apps, maybe prototypes, if you're a web dev, it was pretty accessible. Get started quickly.
And it had plugins for native stuff like the camera.
Yep, a plugin architecture to bridge that gap between the web code and the device features.
But looking at our sources here, Cordova had some pretty well-known problems. Performance seems like a big one.
Oh, definitely.
Yeah.
Because everything ran in that web view, it often felt sluggish, compared to a native app at least.
How much slower are we talking?
Some reports mention, potentially up to 40% slower in certain cases,
Mm-hmm.
especially with complex UIs or animations. That abstraction layer, it just added overhead.
And the UI consistency. I definitely remember apps built with it that just felt a bit off. Not quite native.
Yeah, that was a real headache. Web views could render differently depending on the device, the OS version.
So getting that pixel-perfect native look was tough.
Very tough. It often felt less polished, less integrated than a true native app.
And I see a note here about plugin chaos. Sounds,
What?
well, chaotic.
It really could be. There were tons of plugins, but the quality, the maintenance, compatibility, it was all over the place.
So finding a good, stable plugin was hit or miss.
Sometimes, yeah. And building your own custom plugins was described as tedious. It was just a fragmented landscape.
Okay, so Cordova. Accessible for web devs, but struggling with performance, UI consistency, plugin reliability. What came next?
React Native. That was a pretty big step up,
Yeah.
launched by Facebook around 2015.
How did that change things? No web view.
Right, no web view for the main UI.
Yeah.
Instead, it used something called a bridge to talk to actual native UI components.
Ah, okay, so you'd get real native buttons, native lists, that kind of thing.
Exactly. Which generally meant a much better native look and feel and usually better performance than the web view approach.
Plus, it tapped into JavaScript and React, which were already huge.
Massive community, yeah. Huge ecosystem advantage. And they introduced things like hot reloading.
Which was a game changer, right? Seeing your changes almost instantly.
Absolutely. Big productivity boost. But React Native wasn't perfect either. It had its own set of challenges.
Like the bridge itself.
Yeah, that JavaScript bridge could actually become a performance bottleneck sometimes.
How so?
If your app had a lot of back and forth communication between the JavaScript side and the native side, you could hit performance issues. Little stutters, people call it jank.
Okay. And managing the native side could be complex too.
It could be. Dealing with native dependencies, different build systems, maybe even C++ errors if you weren't careful.
Yeah.
It wasn't always smooth sailing, especially without deep native experience.
And UI consistency, while better, still wasn't always perfect out of the box.
Sometimes you still needed platform-specific tweaks to get things looking exactly right, because native components themselves can have subtle differences across manufacturers or OS versions.
Got it. So Cordova had its issues. React Native improved things, but introduced its own complexities with the bridge and native dependencies. Where does Flutter enter the story?
So Flutter, coming from Google, really aimed to learn from all that history. They designed it from the ground up to tackle those core problems in a fundamentally different way.
Different how? What's the core technical idea?
The absolute biggest difference is rendering. Flutter doesn't use web views, and it doesn't use the platform's native UI components either.
So what does it use?
It brings its own engine. It uses Skia, a high-performance 2D graphics engine to draw every single pixel on the screen itself.
Skia, isn't that used in Chrome and Android?
The very same. It's a mature, powerful C++ engine. Flutter basically bundles Skia and its framework and paints its UI directly onto a surface provided by the OS.
Okay, hang on. Drawing every pixel, why is that such a big deal?
Two main reasons. First, consistency. Because Flutter controls the rendering, it guarantees that your UI looks exactly the same across all devices, all OS versions. Pixel-perfect consistency.
Ah, solves the inconsistency problem of WebViews and even the subtle native component differences.
Precisely. Second, performance. Because it controls the entire rendering pipeline, it can optimize heavily for smooth animations, aiming for 60, even 120 frames per second directly using the device's GPU.
So it tackles both the UI consistency and the performance limitations of earlier approaches.
That's the core goal. And the language it uses is Dart.
Dart, why Dart?
Google chose Dart because it's, well, optimized for building UIs. It has a productive syntax, familiar to Java or C# devs, and crucially, it compiles directly to native machine code for mobile and desktop.
No bridge needed for the UI rendering part.
Exactly. Or it can compile to JavaScript for the web. That direct compilation is key for performance.
You mentioned compilation. I see notes about AOT and JIT.
Right. Flutter uses both. During development, it uses JIT, just-in-time compilation. This is what powers the amazing Stateful Hot Reload.
That's the feature everyone talks about.
It is. You save your code, and boom, the UI updates almost instantly without losing your app's current state. It makes building UIs incredibly fast.
And for release.
For release builds, it switches to AOT, ahead-of-time compilation. This compiles your Dart code into fast, optimized native machine code before the user even installs the app.
Which means faster startup, smoother runtime performance.
Exactly. Better performance, more predictable behavior. Sort of gives you the best of both worlds. Fast iteration during development, high performance in production.
That sounds like a really smart approach. How is the UI actually built then?
It's all based on widgets.
Yeah.
The philosophy is everything is a widget.
Yeah.
Buttons, layouts, padding, themes, they're all widgets.
And you compose them together?
You build a widget tree.
Yeah.
Flutter provides a really rich set of pre-built widgets that mimic material design for that Android feel and Cupertino widgets for the iOS look.
So you can make apps look native-ish easily?
Yes, or you could build completely custom designs.
Mm.
That control is there because, again, it's drawing everything itself.
Okay, let's connect this back. How does this architecture specifically solve the pain points we discussed with Cordova and React Native?
Okay, UI consistency. By owning the rendering with Skia, Flutter completely sidesteps the WebView inconsistencies and the potential differences between platform-native components. You get that pixel-perfect consistency.
No more tiny alignment issues between platforms.
Hopefully not. And performance. AOT compilation plus Skia, drawing directly to the GPU, avoids both the general sluggishness of WebViews and the potential bottlenecks of the JavaScript bridge found in older React Native architectures. It aims for that consistent, smooth, 60, 120 FPS.
Makes sense. What about the plugin chaos from the Cordova days?
Flutter tackled that with pub.dev. It's a centralized repository for Dart and Flutter packages.
Centralized is good.
Yeah, and they added things like pub points scores based on code health, documentation, platform support, and the Flutter Favorites program to highlight high-quality, well-maintained packages.
So trying to guide developers towards better plugins.
Exactly. It helps mitigate that risk of fragmentation and abandoned packages. Accessing native device features is done through something called platform channels.
Platform channels.
It's a structured way for the Dart code to send asynchronous messages back and forth with the native platform code, Kotlin Java on Android, Swift Objective-C on iOS. And importantly, Google maintains many core plugins themselves, things like camera, Firebase integration, sensors.
Ah, official maintenance adds a layer of trust and stability.
Definitely. And the overall developer experience, or DX.
What's that like?
Flutter puts a big emphasis here. Setup is often smoother thanks to tools like Flutter Doctor, which checks your environment.
That's helpful.
Debugging tools like Flutter DevTools are quite comprehensive. Widget inspectors, performance profilers, all in a web-based interface. And Stateful Hot Reload, as we said, is just a massive productivity win for UI work and debugging.
What about managing app state? That can get complex.
Flutter has a strong focus on state management, with a well-developed ecosystem of patterns and libraries like Provider, VLSC, Riverpod. There are clear, documented approaches, which wasn't always the case with earlier frameworks.
And the learning curve, learning Dart.
You do need to learn Dart, which is a hurdle if you're coming purely from JavaScript. But for developers with backgrounds in Java, C# or other object-oriented languages, Dart often feels quite familiar and relatively easy to pick up. Plus, the excellent official documentation and the productivity gains from Hot Reload help offset that initial learning investment.
Okay, the technical story sounds pretty solid. It seems engineered to address those historical issues. But does the real world reflect this? What does the adoption data actually show?
The adoption numbers are, well, pretty impressive. They show really significant growth and developer interest.
Like what? Give me some examples from the sources.
Okay, developer surveys are a good indicator. Stack Overflow's 2024 survey, for instance, ranked Flutter as the #1 most used cross-platform tech.
Most used. What about satisfaction?
That's maybe even more telling. It's been the #1 most loved framework for, I think, 4 years running in that survey. Developers who use it tend to really like it.
High satisfaction is definitely a strong signal. What about code repositories?
If you look at GitHub, as of early 2025, Flutter's main repository had significantly more stars than React Native's. And looking at the number of repositories using the tech, Flutter has also pulled ahead there, according to some 2024 reports.
And general interest.
Google Trends data shows Flutter dominating global search interest compared to React Native consistently since around April 2020.
Okay, so developers seem keen. Are they actually building apps with it?
Yes, definitely. Estimates from mid-2023 suggested over 1 million Flutter apps were already on the Google Play Store. And market share data from early 2025, like from App Figures or Stack Overflow surveys, consistently puts Flutter's share of the cross-platform market at over 45%, some even suggesting closer to 47% for new projects.
Wow, nearly half of new cross-platform apps. That's substantial.
It shows real momentum. And the estimated developer base is growing rapidly too, potentially surpassing 5 million globally by early 2025, according to some sources.
That's a big community. What about the ecosystem supporting them? Packages, tools?
Pub.dev, the package manager we mentioned, is central. It hosts tens of thousands of packages now. The quality checks like pub points and Flutter favorites really help navigate that.
Avoids the old plugin chaos.
That's the aim. The official tooling Flutter Doctor, DevTools, Hot Reload, excellent IDE integration with VS Code and Android Studio is very strong. And you're seeing third-party tools emerge too, like Flutterflow, a low-code visual builder. That signals ecosystem maturity.
And learning resources.
Really top-notch. The official Flutter documentation is widely praised. There are tons of code labs, tutorials, online courses on platforms like Udemy, Udacity, Coursera, and a very active community creating content on YouTube, blogs, forums.
Okay, strong developer adoption, growing ecosystem. What about big companies? Are serious enterprises adopting Flutter for critical apps?
Absolutely. And this is key validation. We see case studies, like Google Pay, obviously, migrating their main app to Flutter. They reported things like a 40% reduction in development time and hitting 99.99% uptime. That's significant.
Google using its own tech makes sense, but who else?
BMW used Flutter for their My BMW app, citing unified user experience and reduced costs. Alibaba uses it in their Shanyu app, which has like 50 million users, and they reported better responsiveness and cutting feature development time drastically.
Shanyu, that's a huge app.
Massive. eBay Motors also reported faster development, like 40% faster, and reduced maintenance using Flutter. Tencent uses it. Other big names mentioned include Reflectly, the Hamilton musical app, the New York Times, Groupon, Philips Hue, Realtor.com, Nubank.
Okay, that's a pretty convincing list of real-world, large-scale deployments. It suggests Flutter is definitely enterprise-ready.
It certainly makes a strong case for it.
Now we have to ask, how much of this incredible success story is purely down to Google's backing? Is it just Google pushing its own thing?
Google's role is undeniably huge. It's probably the single biggest catalyst for Flutter's rapid rise.
How so?
Well, first, they provide a large, dedicated core engineering team. That means continuous development, bug fixes, new features. They invest significant financial resources. Second, as we mentioned, they use Flutter internally for major apps like Google Pay and Google Ads.
Dog fooding, right? Eating your own dog food.
Exactly. That internal use at scale is powerful validation. It shows they trust it for mission-critical stuff, which gives other companies confidence. They also actively nurture the ecosystem, sponsoring events, maintaining core plugins, running pub.dev, and there's the strategic alignment with Android and potentially future OS like Fuchsia.
So Google's backing provides credibility, resources, stability, and significantly de-risks adoption for companies.
Absolutely. While the tech has its own merits, Google's support has been a massive amplifier, accelerating its journey to becoming a dominant player.
Okay, so we have a technically innovative framework, Strong adoption metrics, major corporate use, and significant backing from Google. Let's put it head-to-head with its main rival today, React Native. How do they compare in, say, 2025?
Right, they're definitely the two heavyweights in cross-platform mobile development now, but with quite different philosophies still.
Let's start with maturity and stability.
Okay, React Native is older, launched in 2015. That means a vast ecosystem of libraries available through NPM. It's very established.
Yeah.
But the sheer size means quality and maintenance of third-party packages can be inconsistent. Debugging issues related to the native bridge historically could also be complex.
And Flutter.
Flutter, stable since 2018, is younger, but has matured incredibly quickly, largely thanks to that Google investment. The pub.dev ecosystem, with its curation efforts, aims for a higher baseline of package quality and stability. Plus, Dart's strong typing can help catch errors earlier. Although we should note, even Flutter isn't immune to ecosystem bumps, like the recent news about Goddard needing new maintainers. Maturity is an ongoing process.
Right. Okay, performance, this seems like a key battleground, especially with React Native's new architecture.
It is, and it's become much more nuanced. Historically, Flutter often had a clear edge due to its direct rendering, avoiding the JS bridge bottleneck that could cause jank in React Native.
But React Native has evolved.
Significantly. Their new architecture, using things like the Hermes engine, Fabric for the UI layer, Turbo modules, and the JavaScript interface, JSI, enabling bridgeless communication, is specifically designed to eliminate those old bridge bottlenecks.
So much closer communication between JS and native.
Yeah, potentially much more direct and efficient. They're also leveraging things like concurrent rendering from React itself.
And Flutter's performance story now? Still Skia.
Still Skia. And they're rolling out a new rendering engine called Impeller, designed to further improve performance and eliminate shader compilation jank, especially in iOS Metal. Combined with AOT compilation, it still delivers very strong, smooth performance, particularly excelling in complex UIs and custom animations, where it has that direct GPU control.
So comparing them today, has the gap closed?
For many typical business apps, yes, the performance gap has narrowed significantly. React Native's new architecture has made a big difference. Flutter might still have an advantage in scenarios demanding extreme graphical performance, intricate animations, or absolute pixel-level control. Another area often cited is performance on lower-end devices, where Flutter's lighter runtime compared to bundling a JS engine can be beneficial.
So it's not a simple win for either side anymore, more use case specific.
Exactly. The debate is much more nuanced now. Performance is less likely to be the sole deciding factor for many mainstream apps than it perhaps was a few years ago.
Okay, what about developer productivity?
Flutter's Stateful Hot Reload is still frequently cited as faster and more reliable than React Native's fast refresh, leading to quicker UI iteration cycles.
Learning curve.
React Native has the advantage here for teams already skilled in JavaScript, and React the talent pool is enormous. Flutter requires learning Dart, which, as we said, is relatively easy for OOP devs, but still an extra step. However, Flutter's excellent documentation and tooling help onboard developers quickly.
And actually building the UI.
Flutter's comprehensive built-in widget sets, Material Cupertino, and the ability to easily create custom widgets allow for very rapid development of consistent, often highly branded UIs. React Native uses platform-native components, which gives an authentic native feel out of the box, but might require more effort for perfect cross-platform consistency or deep customization.
Ecosystem access.
React Native taps into the vast NPM ecosystem. Flutter relies on the smaller but growing and more curated pub.dev.
Enterprise readiness, scalability, maintainability.
Both are proven at scale. You have giants like Instagram and Airbnb using React Native, and Google Pay and Xiaoyu using Flutter. Flutter's single, coherent architecture and codebase can potentially simplify long-term maintenance for multi-platform projects. React Native's heavy reliance on third-party libraries can sometimes introduce maintenance challenges if those libraries aren't well supported.
Security, talent pool.
Both can be made secure with due diligence. Some might argue Flutter's core plugins being officially maintained offers a slight edge in consistent vetting, whereas RN requires careful selection of community packages. Talent pool, as mentioned, is currently larger for JS React Native, making hiring potentially easier, although the Flutter pool is growing fast and is skilled. Flutter devs are in high demand.
How about web and desktop support? That's a big part of Flutter's pitch now.
It is. Flutter offers official support for web, Windows, Mac OS, and Linux, all from that single codebase. The goal is consistent rendering Flutter everywhere.
How well does it work in practice?
It's stable and usable, but still maturing compared to mobile. Web apps built with Flutter can have a larger initial load size than typical JS frameworks, potential SEO challenges depending on the renderer, CanvasKit versus HTML, and the plugin ecosystem for web-specific features is less developed. It's great for PWAs or complex web applications, maybe less ideal for simple, content-heavy websites.
And desktop.
Similar story. Official support is there, but the ecosystem of desktop-specific plugins is smaller. Deep OS integrations might require custom platform channel code. App size would also be noticeable. A basic Hello World macOS app might be 50 megabytes or more because it bundles the engine. Performance is generally good, but some perceive overhead for very complex desktop UIs compared to native desktop frameworks.
How does React Native compare on web desktop?
It's not a core focus. Support comes mainly via community projects like React Native Web or Microsoft-backed efforts like React Native Windows and React Native macOS. It often feels more like adapting a mobile paradigm to these platforms, rather than Flutter's approach of aiming for consistent rendering across them. Integration can sometimes feel less seamless.
So a philosophical difference there. Flutter aims for consistency. RN adapts.
Kind of, yeah. Flutter offers a more unified path if your strategy requires truly consistent UI/UX across mobile, web, and desktop from one code base, even if the web desktop targets are still maturing.
Okay, summing up the comparison. Both are strong, mature leaders now. React Native leverages the massive JS ecosystem and native components, especially with its new architecture closing the performance gap. Flutter offers unique advantages through its custom rendering engine consistency, potentially smoother complex UIs, great tooling like Hot Reload, and a more unified multi-platform story, all heavily backed by Google.
That's a fair summary. The best choice really depends on the project specifics, team skills, and strategic priorities.
This naturally leads to the question. With these powerful cross-platform tools, is there still a need for pure native development using Swift for iOS or Kotlin for Android?
Oh, absolutely. Native development isn't going away. It's still the optimal choice in certain specific demanding situations.
Like when? What are the scenarios where native still wins?
Number one is usually absolute peak performance and resource efficiency.
Okay. Things like
High-end 3D games, complex augmented reality or virtual reality experiences, applications doing heavy real-time signal processing like custom camera filters or audio manipulation. Native code generally offers the lowest overhead and the most direct access to hardware acceleration. Native apps also tend to load slightly faster, maybe around 15% faster in some studies.
okay, extreme performance needs. What else?
Deep hardware or OS-level integrations. If your app needs immediate access, the very latest platform features brand new sensors, cutting-edge OS APIs, deep system hooks the moment they are released by Apple or Google.
Before cross-platform frameworks have time to add support.
Exactly. Native gives you day one access. Cross-platform frameworks always have some lag in adopting brand new platform-specific capabilities.
Makes sense. How about UI UX?
If your product demands perfect adherence to the absolute latest, constantly evolving native design guidelines and UI conventions of iOS or Android, and any slight deviation is unacceptable, then native is the safest bet. Flutter does a great job emulating native looks with Material and Cupertino, but native is native.
So if being indistinguishable from a first-party app is the absolute top priority.
Right. Also sometimes for security or compliance reasons. If you need to leverage very specific platform security features or hardware-level security elements for strict compliance standards, like IPA, using native SDKs directly might be mandated or preferred over relying on third-party cross-platform plugins, even if those plugins are well-vetted.
Got it. So native offers maximum control, performance, and integration, but the trade-off is building and maintaining two separate code bases.
That's the fundamental trade-off. Higher cost, slower time to market for multi-platform, but ultimate control.
So how does a team decide? What are the key criteria when choosing between native, Flutter, or React Native?
It really comes down to weighing several factors strategically. First, team expertise and skill set. What are your developers already good at? Native Swift Kotlin, Dardo JavaScript React. Leveraging existing skills is often faster.
Time to market versus performance and complexity.
Yes, cross-platform, especially Flutter with its hot reload, can be significantly faster for getting an MVP out on both platforms. But if you hit those extreme performance or complexity ceilings we discussed, native might be required, even if it takes longer.
Legend and cost, obviously.
Native development is almost always more expensive due to needing separate teams or developers skilled in both platforms, plus dual maintenance efforts. Cross-platform offers significant cost savings through code reuse.
What about long-term maintenance and evolution?
A single code base with Flutter or React Native simplifies core logic updates. However, you do need to manage updates to the cross-platform framework itself, which can sometimes require effort. With Native, you manage two separate update streams.
Third-party SDKs.
This is critical. Before committing to cross-platform, you must verify that any essential native SDKs or services you rely on have high-quality, well-maintained plugins available. Check pub.dev for Flutter, npm for React Native. If a critical SDK isn't supported, Native might be your only option.
And finally, user experience expectations.
How important is that perfect, platform-specific native feel versus a consistent, potentially branded look across platforms? If strict native fidelity is paramount, lean towards native. If a beautiful, consistent brand-first UI is the goal, Flutter is exceptionally strong there, while still offering good native emulation via Material Cupertino. React Native offers a native feel via components, but might need tweaking for perfect consistency.
So it's about finding the best strategic fit. It sounds like cross-platform, particularly Flutter, is now good enough, or even better for a huge range of apps, making native more of a specific choice for the extremes.
I think that's a very accurate way to put it. The default choice has shifted for many use cases.
Okay, let's be balanced. No technology is perfect. What are the main challenges or criticisms still leveled at Flutter based on our sources?
Probably the most frequently mentioned one is app size,
Why are Flutter apps typically larger?
because they have to bundle the Flutter engine, Skia or Impeller, and the Dart runtime along with the app code. This adds a baseline size overhead.
How much overhead are we talking?
Even a simple Hello World Android app might be 10-15 millibaters or more, compared to potentially much smaller native equivalents. A basic macOS desktop app could be around 50 millibytes. While techniques like app bundles, code splitting, and tree shaking help reduce the final download size, the initial installed size is just inherently larger.
And that's a concern for...
Users with limited device storage or those on slow or expensive mobile data connections. It's a trade-off for the benefits Flutter provides.
Okay, app size. What else?
Platform-specific UX nuances. Because Flutter draws everything itself, it has the responsibility of perfectly replicating all the subtle native behaviors, scrolling physics, animations, gesture responses, dialogue appearances, text selection, accessibility features.
And keeping up with changes in iOS and Android.
Exactly. The Material and Cupertino widget libraries do a fantastic job, but ensuring they're always perfectly in sync with every minor change or new idiom introduced in the latest OS versions is an ongoing challenge. There can sometimes be subtle discrepancies that sharp-eyed users might notice.
The second-class citizen perception.
Yes, some argue that because it's not developed by the core OS teams at Apple and Google, Flutter will always be playing a bit of catch-up in adopting the absolute latest native UI trends or features compared to native development.
Makes sense. You also mentioned web and desktop maturity earlier.
Right. While officially stable, they're generally considered less mature than Flutter's mobile support. We touched on the web limitations. Potential performance differences compared to optimized JS frameworks, the initial load size, SEO considerations with CanvasKit, browser compatibility nuances, a smaller plugin ecosystem, and sometimes complex JavaScript interoperability. It's not always the best fit for every type of web project, especially simple content sites.
And desktop limitations.
Similar themes. A less developed plugin ecosystem compared to mobile, needing custom code for deep OS feature access, the app size issue we mentioned, and sometimes needing a shift in mindset to design UIs that feel truly idiomatic for desktop users. Performance for very complex desktop apps can also be a concern for some.
What about Dart itself? Its adoption outside of Flutter.
That's another point often raised. Dart's primary, almost exclusive major use case is Flutter. Its adoption for other things, like server-side development or general-purpose scripting, is pretty limited compared to languages like JavaScript, Python, or Java.
And the impact of that.
It means the pool of developers who already know Dart, outside of those specifically learning it for Flutter, is smaller than for, say, JavaScript. This can affect hiring, though, as we noted, the Flutter community itself is large and growing rapidly, bringing more people to Dart. And Google is trying to expand its use, like with the recent generative AI SDK for Dart.
Are there any other common developer criticisms?
Some sources mention variability in the quality or maintenance of community plugins, though pub.dev helps. Occasionally, people report performance issues or jank, although often these can be traced back to inefficient application code rather than the framework itself. Historically, there were limitations with things like integrating WebViews within Flutter apps, though that has improved. And some find configuring complex native integrations or specific build flavors can still have a learning curve, although tooling improvements have helped there too.
So these seem like known challenges, many inherent to the ambitious goal of a custom rendering, multi-platform framework, and areas the team and community are actively addressing.
Exactly. They're trade-offs and areas for continued improvement rather than fundamental deal breakers for most projects.
Okay, let's wrap this up. We've gone through the history, the tech, the Adobasa comparisons, the challenges. What's the final verdict from our sources? Is Flutter a genuine evolution in cross-platform, or was it mostly a Google-boosted experiment?
Based on all the evidence we've discussed, the unique technical approach that directly solves historical cross-platform problems, the widespread developer and corporate adoption, the high satisfaction rates, the thriving ecosystem, the conclusion seems pretty clear. Flutter represents a genuine evolution
Why genuine evolution? What makes it more than just another iteration?
because its core architectural decision, owning the rendering via SkyImpeller, fundamentally addresses the root causes of UI inconsistency and performance bottlenecks that plagued earlier solutions like Cordova, WebViews, and React Native, the original bridge architecture. It wasn't just an incremental improvement, it was a different approach designed to solve those specific problems from the ground up.
And the technical merits stand on their own.
Yes. Features like AOT and JIT compilation, Stateful Hot Reload, the expressive widget system, the curated package ecosystem, these provide tangible benefits to developers regardless of who backs the project. Now, was Google's backing a massive catalyst? Absolutely. It provided the resources, credibility, and push needed for rapid growth and validation. But the underlying technology is sound and solves real problems effectively.
And the proof is in the pudding. The sheer number of apps and companies successfully using it shows it's far beyond just an experiment.
Precisely. It has found significant product market fit.
So distilling everything down, if someone listening is trying to decide on a platform today, what are the key takeaways? When should they choose Flutter?
Okay, choose Flutter when. You need high fidelity UI, strong brand consistency across platforms. When complex animations, custom visuals, and a polished look are critical. When rapid development cycles and quick iteration using hot reload are important, maybe for an MVP. When your strategy involves targeting mobile, web, and desktop from a single code base. When strong performance for most common application types is a priority. And of course, if your team has an OOP background or is willing and eager to learn Dart.
And when should they still lean towards native development?
Consider native when. You require the absolute maximum performance possible for things like cutting-edge games, AR/VR. When you need immediate day-one access to the very latest OS features or hardware capabilities. When perfect, pixel-for-pixel adherence to the constantly evolving native platform look and feel is non-negotiable. Or if the app is only targeting a single platform anyway and budget time permit dedicated native development. And of course, don't forget React Native. It remains a very strong alternative, especially compelling for teams already heavily invested in JavaScript and React, or those who prefer using actual native UI components out of the box, keeping in mind its own strengths and trade-offs, particularly with the new architecture improvements.
This has been a really thorough deep dive. It feels like we've really unpacked Flutter's journey and its current position. It's clear it represents a major step forward in the cross-platform world, offering compelling solutions to old problems, even with its own set of trade-offs.
Definitely. It's moved the needle significantly. The conversation is less about if cross-platform is viable and more about which approach, Flutter, React Native, or even native, best aligns with your specific project's needs and constraints.
Well, thanks so much for walking us through all this source material and laying it out so clearly. Hopefully, for everyone listening, this gives you a much more informed perspective on where Flutter fits into the mobile and multi-platform development landscape today.
My pleasure. It's a fascinating space, always evolving. Understanding these tools is crucial for making smart tech choices.
Couldn't agree more. And be sure to subscribe to Joy of Architecture so you don't miss our future deep dives.